Mazda has introduced a new electronically controlled automatic transmission in the 626. As the name suggests, electronics are used to control the transmission. The ECAT is outlined in this illustration. A variety of sensors and switches are used to detect the vehicle's operating conditions. Data from these sensors and switchers is gathered in the ECAT control unit, which then issues appropriately timed commands to change gears or lock up the torque converter. Solenoid valves in the transmission function according to these commands to control the hydraulic pressure and effect gear changes and torque converter lockup. Unlike conventional automatic transmissions, which changed gears according to governor pressure, this new system allows more precise control of the gear selection. The 626 is Mazda's first front-engine, front-wheel drive car to offer both overdrive and lockup. The result is greater fuel economy and driving performance. In this video, we will first examine the structure of the new ECAT, and in part 2, we will then cover how to use the new ECAT tester, an essential new tool in ECAT maintenance. The ECAT can be divided into two main parts. Let's take another look at this illustration. First, there's the sensors, switches, control unit, and other components in the electronic system required for signal processing. Second, there's the mechanical system, which actually works the valves and changes the gears. First, let's examine the electronics. The sensors and switches might be compared with man's eyes and ears, as these are where all information required for system operation is received. Now, we will examine these sensors and switches. Two sensors are used to detect basic transmission and lockup data. First is the throttle sensor. This is mounted in the throttle body. The throttle sensor converts the throttle valve opening to an electrical signal and transmits this to the control unit. Second is the pulse generator. The pulse generator detects the speed of the reverse forward drum. Now, let's see how this works. A coil is built into the pulse generator. The coil is essentially an electrical generator. Each time a projection on the reverse forward drum passes the pulse generator, the inductance motive force of the coil is interrupted and creates the pulse. These pulses are counted within the ECAT control unit to detect the drum speed. The ECAT is controlled according to these two data, to shift or create lockup. To enable even more precise control, however, a variety of other sensors and switches are also used. These sensors and switches relay the current vehicle operating conditions and driver commands to the ECAT control unit. The control unit, in turn, processes the incoming signals and issues commands to either shift or create lockup. The control unit could be thought of as the brains for the ECAT. Now, let's consider the mode judgment procedure. Mode judgment decisions are, of course, made by the driver. In addition, the control unit supplements this by using the signal from the water temperature switch to automatically select the power mode, regardless of the mode switch position, if the engine coolant temperature is below a specified point. This assures the most comfortable vehicle operation. Another decision made by the control unit is range judgment. Range judgment is made in accordance with which inhibitor switches have been activated by the driver setting the gear selector. Other control unit decisions include overdrive inhibit judgment, lockup available, shift, and lockup judgment. In addition, these sensors and valves are also constantly monitored by the fail-safe function to assure safe driving. In the event a malfunction occurs, the driver is immediately alerted and the fail-safe functions to assure the safest possible operation. In addition, the malfunction is stored as a code within the control unit and can be retrieved and later identified using the ECAT tester. As seen, it is clear that the role of the electronic system is to accurately summarize the vehicle operating conditions and driver commands, and to process this data to adjust vehicle operation for the safest, most economical, and most pleasurable driving. It is the mechanical system which receives commands from the control unit and either shifts gears or provides lockup. Let's examine the mechanical system by first reviewing its structure. This is a torque converter. The lockup mechanism is built into this unit. Next is the reverse forward drum. Inside this are 3 clutches and a one-way clutch. And here's another one-way clutch. The low and reverse brake. Then comes the planetary gears. The transmission gear ratio is determined by the combination of planetary gears engaged. This is the 3/4 clutch for 3rd and 4th gears. And the output shell. These different parts combine to form the mechanical system. Now, let's see how this new system differs from the conventional F3A transmission. The first thing to consider is transmission control. In a standard F3A transmission, shifting is controlled according to the governor pressure, which varies with the vehicle speed. In the ECAT, however, the transmission is controlled by changing the on-off pattern of the solenoid valves. Let's consider this, beginning with the shift valve action. The shift valve engages the clutch with hydraulic pressure to adjust the gear ratio. There are 3 shift valves, one for each shifting from 1st to 2nd, 2nd to 3rd, and 3rd to 4th. We will use the shift valve for shifting from 2nd to 3rd to further examine shift valve operation. During 2nd gear, the line pressure is drained and the valve is pushed to the right by the spring because the solenoid is on. When the solenoid is switched off by a command from the CU, the line pressure is applied to the 2-3 shift valve, and the valve overcomes the spring force and moves to the left. When this happens, engagement pressure is applied to the 3/4 clutch, causing engagement. At this time, the 3/4 shift valve moves, and the coasting clutch is engaged. Next is the lockup mechanism. This is the lockup control valve in the no lockup position. The valve is held open by the line pressure, and torque converter pressure is applied to the damper piston. The damper piston is released from the converter cover, and the converter does not lock up. During lockup, the line pressure is drained according to the solenoid command. This causes the lockup control valve to be pushed by the spring, and to drain the pressure at the front side of the damper piston and lock up the converter. Now, let's take a look at the throttle valve, which adjusts the clutch pressure. In the F3A transmission, the throttle valve is operated by the intake manifold vacuum. But in the ECAT, the throttle valve is operated by the throttle cable connected to the accelerator. The throttle valve repeats this action to control the throttle pressure and therefore the clutch pressure. The planetary gears are used to change the gear ratio. Let's examine these next. Two planetary gears were used in the F3A. But in the ECAT, one compact combination-type planetary gear is used. This compact combination planetary gear is designed as shown here. We will examine planetary gear operation for the various gear ratios with this model. First, of course, is first gear. Then second, third, fourth, or overdrive, and finally, reverse. As our last point, let's take a look at oil pump operation. The ECAT oil pump is a variable chamber vane pump. This type of pump is a variable output pump. It reduces engine output loss due to excessive oil feed as compared to the F3A gear type pump. Output is adjusted as illustrated here. When the engine speed is low, the valve within the pump closes the port to the variable chamber. In this condition, the amount of oil discharge increases corresponding to the engine speed. Because the valve outlet is restricted in conjunction with the increase in engine speed, it is pressed by the pressure within the valve, and the valve moves to the right. When this happens, the port to the variable chamber opens, and the oil flow is guided. When the pressure within the variable chamber increases and overcomes the spring force, the capacity of the pump chamber becomes smaller, and the discharge amount is reduced. In this way, then, the oil discharge amount is adjusted. For further details and a more in-depth discussion of the electronically controlled automatic transmission, please refer to the training manual. The ECAT will be an integral part of many future Mazda vehicles, and we hope you will take this opportunity to thoroughly familiarize yourself with it. In Part 2, we will explain how to use the ECAT tester, an essential new tool in electronically controlled automatic transmission maintenance. This tester displays the control unit input signal. Output signal, throttle valve opening, and vehicle speed to simplify ECAT inspection for quicker maintenance. Before starting the description of tester operation, let's first review a few basic inspection procedures required before inspection. Throttle cable inspection was one procedure which was not necessary with a conventional F3A automatic transmission. Accordingly, let's see what throttle cable inspection entails. First, check the outside of the cable for any visible defects or problems. Next, work the accelerator to make sure the accelerator and cable move smoothly. Then, open the throttle valve all the way and measure the length of the cable as shown here. If the cable length is not within the specified length of 46 millimeters, plus or minus 0.2 millimeters, or 1.81 inches, plus or minus 0.008 inches, adjust the length with a lock nut. Connect the ECAT tester after the basic inspection is completed. First, connect the ECAT tester's 6-pin connector to the service connector, and also make the ground connection. In this condition, check the malfunction location by the inspection code. This inspection code tells what sensors or valves were determined to be defective by the self-diagnosis function of the control unit mentioned briefly in Part 1. When the ignition switch is turned on, a buzzer will sound for 3 seconds. A 00 will be displayed if no defect is found. If a problem is found, the code number for the defect will be displayed and the buzzer sounds. If 2 or more defects are found, the smaller code numbers stored in the memory will be displayed first. Press the overdrive button twice to display each successive code number. When all code numbers have been displayed once, the first code number displayed will appear once more. The self-diagnostic function of the control unit stores all sensor and valve-related problems. Accordingly, be sure to disconnect the battery cable for at least 3 seconds after repairs are completed to clear the memory. After finishing the inspection code checking, connect the remaining connectors. Pass the cable underneath the brake pedal. Make sure it does not interfere with pedal operation. Then check the input signal first. This inspection checks to make sure all switches and sensors are properly relaying driver commands and vehicle operation signals to the control unit. Consider the inhibitor switch. When the gear selector is set to a specific range, the indicator for that position should light. The indicator for the mode switch should only light when the economy mode is selected. For other signals, please refer to the workshop manual. Now let's review output signal inspection. In this inspection, we are checking to make sure the correct output signals are output based on the incoming input signals. Using the solenoid valve as an example, the tester indicator should light as you see here when the gear selector is set to park. When reverse is selected, this should appear. When inspecting the air conditioner cutoff relay, and make sure the indicator lights. This indicator should remain lit for approximately 3 seconds after the accelerator is released. If the accelerator is held depressed, the indicator should go out in approximately 15 seconds. Next is the driving test. This test is to determine if upshift, downshift, and lockup on and off are performed according to the specified gear shift and lockup patterns. This test should be performed either on the road or on chassis rollers. First, check the gear shift position. This test should be performed in 4 patterns. That is for first, second, drive economy, and drive power. In this example, the economy mode drive range is used. Turn the overdrive switch on for 4th gear. Make sure the water temperature switch is off. If the switch indicator is on, the power mode is selected. Set the throttle sensor voltage to 0.9 volts by moving the throttle pedal to about 1/8 open. Increase the speed and check the vehicle speed when shift occurs. Compare the gear shift and lockup pattern shift points. Make sure to make the same comparison while decelerating. If there's no problem in the electronics, but the gear shift point differs anyway, use the slippage test to determine if the transmission itself may be at fault. Also, check the relationship between reverse-forward drum speed and vehicle speed. In first gear, vehicle speed should be 21 kilometers per hour, or 13 miles per hour, to 23 kilometers per hour, or 14.3 miles per hour, when the reverse-forward drum speed is approximately 2,000 RPM. For vehicle speeds in the other gears, please refer to the workshop manual. Now, let's take a look at lockup. As before, drive with the voltage at 0.9 volts. Compare vehicle speed when the tester lockup solenoid indicator is lit with the gear shift and lockup pattern when the lockup lights. Also, check the vehicle speed when the indicator goes out during deceleration. To check whether or not the torque converter has actually locked up, momentarily depress the accelerator after the lockup solenoid indicator has lit and after it has gone out. If it is locked, you will feel a shock. This concludes our review of ECAT tester operation. This tester is essential to maintenance and inspection of the new electronically controlled automatic transmission. Please be sure to review ECAT tester operation with the workshop manual. Electronics will undoubtedly be incorporated into more and more products in the future. In addition, more vehicles will surely feature the electronically controlled automatic transmission. We are sure that with this video and the workshop manual, you will have no problem mastering the new maintenance and repair procedures. Thank you for your attention.